Welcome to Understand the Math. In this video, I talk about how to use the horizontal line test to determine if a function has an inverse. We need to understand how this works before we start learning about inverse trigonometric functions. Before you begin, be sure to check out the video description below for a link to free guided notes that you can download and fill in as you watch this video. Let's begin by recognizing that a function will have an inverse if and only if it is a one-to-one function. A function is one-to-one if each output value f of x is associated with only one input value x. Let's see how this works algebraically with three examples. In our first example, f of x is equal to 2x. For this function, different values of x produce different values of f of x. Because of this, we say that f of x is one-to-one. In our second example, f of x is equal to x squared. For this function, some values of x produce the same value of f of x. We can see that if we look at f of 2 and f of minus 2. F of 2 is 2 squared, or 4. F of minus 2 is minus 2 squared, or 4. Two different x values, 2 and minus 2, produce the same f of x value of 4. Because of that, we say that f of x is equal to x squared is not one-to-one. Our third example is f of x is equal to sine x. F of 0 is going to be sine of 0, which is 0. Likewise, f of pi is sine of pi, which is also 0. So this function is not one-to-one because two different x values, 0 and pi, produce the same f of x value, which was 0. So we'll write that sine x is not one-to-one. We can also determine graphically if a function is one-to-one and has an inverse by using the horizontal line test. Here's how the horizontal line test works. We first need to graph the function, and then we'll draw horizontal lines on the graph. If each horizontal line intersects the graph only once, we'll know that the function is one-to-one and it will also have an inverse. Let's return to our three examples and see how the horizontal line test works. Our first function is f of x is equal to 2x, and I've graphed it here. We'll draw a series of horizontal lines and see how many times they intersect the graph. Each horizontal line intersects the graph only once. Because of this, f of x is equal to 2x is one-to-one and has an inverse. Our second function is f of x is equal to x squared. We'll again draw two horizontal lines and see where these lines intersect our graph. We can see that each horizontal line intersects our graph 2 times. If we look at our top line, our point is -2, 4, and our other point is 2, 4. This means for two different values of x, we get the same value for f of x, which is equal to 4. This is the same thing that we saw algebraically. Our last graph is f of x is equal to sine x. For this graph, we're going to draw a horizontal line through the x-axis. We can see that this line intersects our graph at multiple points. Let's make a note that this point is 0, 0, and this next point is pi 0. So for two different values of x, 0 and pi, we got the same value of f of x, which was 0. Again, this agreed with what we saw algebraically on the previous page. Now comes the fun part. Functions that are not one-to-one can be made one-to-one by restricting their domain. This is really important in trigonometry because having a trig function such as sin x be able to have an inverse will allow us to solve equations that have trig functions in them. Let's look at our two examples that didn't have an inverse and see how we can restrict their domain so they can have an inverse. In our first example, f of x is equal to x squared. If we restrict x to be between 0 and infinity, pictured here, we can see that if we draw a horizontal line, it's going to intersect the graph only once. Our function, f of x is equal to x squared, with this restricted domain, is a one-to-one function and does have an inverse. In our second example, if we restrict x to be between minus pi over 2 and pi over 2, and graph the function, we can see that if we draw a horizontal line, that horizontal line intersects the graph only once. This means that our function f of x is equal to sin x when x is restricted to be between minus pi over 2 and pi over 2 is one-to-one and has an inverse. Now we're ready to start learning about inverse trigonometric functions.
If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.